Hello people, welcome back, and today we're going to be looking at the AQA Chemistry 4.4 chemical changes. In the Kabuto book, you're looking at chapter 5 and chapter 6. Okay, so let's jump into it.
It was a nightmare.
Activate.
Right, so here we go. Chemical changes 4.4. So first of all, we're going to be looking at the reactivity of metals, and we start with metal oxides. Okay, essentially what you want to learn from here is that all metals create metal oxides when oxygen is added to. Okay, so oxidation in essence is the addition of oxygen to a metal. Okay, and you should be able to explain reduction and oxidation in terms of loss or gain of oxygen. So oxidation is going to be the gain of the oxygen, and reduction will be taking away the oxygen. All right, and that's what you want to remember in terms of oxygen. Okay, those of you doing higher, you're gonna see why I'm making emphasis on in that in terms of oxygen. Okay, now when looking at reactivity series, this essentially is a list of metals from the most reactive at the top to the least reactive at the bottom. Okay, the only non-metal that actually turns into a positive ion is hydrogen, because normally the metals will turn into positive ions because they give away electrons. Now in the reactivity series, because it's a list of metals from the most reactive to the least reactive, you will think that it will only be metals, but normally we add hydrogen and carbon to the list because they are very commonly used for metal extraction. Okay, so a more reactive metal can displace a least reactive metal, we know that, and then students should be able to recall the reactions between magnesium, sodium, lithium, calcium, zinc, copper with water and acid. So you need to remember how they react. Okay, or just more or less roughly, because you might be given a list of reactions, a table of results with reactions and observations, and you need to deduct yourself and see. You're gonna analyze the information and write down which one is the most reactive and which one is the least reactive. Or they might just ask you to make a practical, to design an experiment on how you would find out which metal is more reactive and which metal is least reactive. Okay, explain how the reactivity of the metals with water and acid is related to the tendency of metal to form positive ions. That's the one thing I told you guys about, that most metals, all metals will turn into positive cations, and with the only exception of hydrogen being turned into a positive cation, which is a non-metal. And deduce the order of reactivity based on experimental results. This is what I'm telling you. They might give you a table of results and you need to try to figure out which one is the most reactive, which one is the least reactive, or sometimes even trying to find out whether a reaction will happen if you add a certain metal from the reactivity series. Okay, now reaction of metals or waters and acid limited to the room temperature do not include reactions with steam. Extraction of metals and reduction. Unreactive metals such as gold are found in the earth as earth metal, but most metals are found as compounds that require chemical reactions for extraction of the metal. Okay, so gold is very unreactive. Normally you can just find gold nuggets, which are pure gold, but any other metal, the majority of the time you will find it as an oxide. Okay, you will find it in a ore, and an ore is a rock with minerals where the mineral is worth extracting. You might get a multiple choice question to ask you to choose what the definition of an ore. Metals less reactive than carbon can be extracted from their oxides with carbon. So anything in the reactivity series, anything that is below carbon, you could heat it up, add carbon to it, and that way you will be able to extract the oxygen from the metal because it will attach itself to the carbon dioxide. And then that's to the carbon, making carbon dioxide and leaving the metal by itself. Okay, reductions involves a loss of oxygen. So we said taking the oxygen away is going to be reduction, adding the oxygen will be oxidation. Knowledge and understanding that are limited to the reduction of oxides using carbon. Knowledge of detailed process used in extraction of metals is not required. Okay, so explaining exactly how the extraction happens, you won't need to do it at this point. Okay, students should be able to interpret and evaluate specific metal extraction processes when given the appropriate information, and identify the substances which are oxidized or reduce in terms of loss and gain of electrons. Okay, so you just gotta familiarize yourself with that. Okay, you gotta just remember what metals are more reactive than other, and if they give you an example and they say, for instance, you have this like the example of, for instance, copper oxide, can you extract it with carbon because carbon is more reactive? You will say yes, and you will try to just briefly describe and explain. Okay, you will say that for instance, the the copper oxide is oxidized because it's got oxygen, and once you add the carbon and you heat it up, it's going to be reduced because you're going to be taking the oxygen away from the copper, but the carbon then is being oxidized because that carbon is being added, the oxygen is being added to the carbon. Okay, now when we're looking at here at oxidations and reduction in terms of electrons, this is only for higher tiers. Okay, so if you're doing triple science, this is for you. If you do not do triple science, you don't really have to worry about this too much. You might not get a question about it, but it's always important that you understand it, or just know about it. Okay, so we said that oxidation is the addition of oxygen, and reduction is taking away that oxygen. Okay, but when you're talking about in terms of electrons, you gotta familiarize yourself with the anagram oil rig. Okay, oil oxidation is loss of electrons, rig reduction is gain of electrons. Okay, oxidation is a loss of electrons, gain, there we go, that's what we said. Write an ionic equation for the displacement reactions. All right, so an ionic equation is just an equation that says this many electrons were added and now we have that, this many electrons were taken away, now we have that. Okay, so for instance, if you have lithium, which is a metal, lithium take away one electron gives you a lithium ion. That's your ionic equation. That's your ionic equation right there. Okay, identify and give in given reaction symbols equation of half equations. So this is important because when we're talking about losing or gaining electrons, if we are talking about, for instance, lithium reacting with something else, because lithium is a metal and the metals always give away electrons, all right, lose is oxidation, oil oxidation is loss of electrons. Okay, and whoever that electron is going to is the one that is being rig, which is reduction, which is the gain of electrons. Okay, so you gotta familiarize yourself and not get it confused with reduction and oxidation, which is addition and taking away of oxygen, or the other one, which is reduction and oxidation in terms of electrons. Okay, those are two different things. Okay, right, so we got reactions with acid. Reactions with acid with metals. Acids react with some of the metals to produce salts and hydrogen. For higher tier, students should be able to explain in terms of gain and loss of electrons these are redox reaction, and identify which species is being oxidized and which one is being reduced. Knowledge of the reaction limited to those of magnesium, zinc, iron. So you only really need to worry about these metals, all right, magnesium, zinc, and iron, reacting with hydrochloric acid and sulfuric acid. Okay, they're not gonna give you any other examples, they're not gonna give you any other metals to work with. If they give you a question on this, they will strictly ask about magnesium reacting with hydrochloric acid and also sulfuric acid, zinc and iron reacting with hydrochloric acid, also sulfuric acid. Okay, that's what you need to know. Okay, but it is important that you know that salts are made. Okay, and the name of the salt is going to depend on the acid and is going to depend on the metal. So for instance, if you have iron reacting with hydrochloric acid, the name of that salt would be iron chloride. If it was reacting with sulfuric acid, the name of the salt would have been iron sulfate. Okay, so the name of the metal always goes first, and then depending on the acid is being used, you're gonna have the second half of that. Okay, and that will be the name of the salt, and you're always gonna get hydrogen regardless of the metal, regardless of the acid. You're always gonna get hydrogen gas. When we're looking at neutralization reaction, acids and salts production. So acid and neutralization by alkali soluble metal hydroxides and bases which are insoluble metal hydroxides and metal oxides to produce salt and water, and by metal carbonates to produce salt and water and carbon dioxide, or particular salts the particulars are present in the reaction between acids and base and alkali depends on. Okay, now it's important that you understand that an alkali, right, is a substance that has a pH of 8 and above but is soluble in water. Okay, a base has a pH of 8 and above but is not soluble in water. Okay, they both will have a high pH, but one of them is soluble in water and the other one is not. Okay, when looking at metal carbonates, they're always gonna give you the salt, they're gonna produce water, and they're gonna produce the carbon dioxide. And then the other ones, instead of giving you hydrogen, but for instance, if you have lithium hydroxide, which is LiOH, that OH is gonna join with the H of the hydrogen that you would have gotten if it was just a metal, and it's gonna give you water instead. All right, so here, so it says acids use hydrochloric acid to produce chlorides, nitric acid to produce nitrates, sulfuric acid to produce sulfates. That's what we just said. The positive ions are in the base, alkali or carbonate. You need to understand what are they. Okay, students should be able to predict from the given reactants, use the formula of common ions and deduce the formula of the salt. So this is basically if they give you a reaction and they say to you, you have lithium and water, what's the name of the salt? Okay, or you have sodium hydroxide and acid, what is the name of the salt? All right, but it doesn't matter because it's always going to be the name of the metal with the combination of the name of the acid. Okay, so just that's easy piece. It's just a matter of you practicing that up. Okay. Soluble salts. Soluble salts can be made from acids by reacting them with solid insoluble substance such as metal oxides, hydroxides, or carbonates. The solids are added until there is no more reactants in excess. This is the required practice. Okay, the majority of the time you will have copper oxide, which is that black fine powder, and they will either ask you to make copper chloride crystals, dry copper chloride crystals, or dry copper sulfate crystals. Okay, and this is very likely to be a 6-mark question. Very, very, very likely to be a 6-mark question. Okay, because it's a required practical, it's very likely that you will get it. Okay, now we'll have a look at that later on, but it's mainly about you being able to write down the process. A lot of the time they give you an example and they will say, why is it that this person didn't get the results that he wanted? Okay, and I remember that it is meant to be like the guy wants to get, I don't know, copper oxide, but he doesn't uses copper, uses magnesium oxide, I think, and then he wants to get copper sulfate crystals, but instead of using sulfuric acid to get the sulfate crystals, he uses hydrochloric acid and gets a chloride instead, right? So it tells you to spot the differences. All right, so you got a couple differences to spot. First of all, you're not using the right metal oxide. Second of all, you're not using the correct acid. And then it's asking you to actually explain what he should have done instead. And then you gotta write down the process yourself. That's only 4 marks. If it doesn't ask you for spelling, grammar, and punctuation, you shouldn't worry too much about it. Just write the sentences and you'll be good. Okay. And then we're looking at the pH scale and neutralization. Okay. Acids produce hydrogen ions. This here, hydrogen ions, is what makes an acid. Okay, and an OH ion is what makes an alkali or a base have a high pH. Okay, the pH scales from 0 to 14 is measure of the acidity or alkalinity of the solution, and can be measured using a universal indicator or a pH probe. Okay, so you have the universal indicator that basically is that green liquid that will change color depending on what you're adding. If you add it to acid, it goes orange, yellow, or red, or maybe sometimes even pink. If you add it to something that is alkali, it will go from light blue to dark blue all the way to purple. Okay, and that's what you got there. Okay, so a solution with a pH neutral zero aqueous solution, and this here, the reaction can be represented by this equation here. That's that image. I can't read it. There you go. Right, so neutralization reaction between acid and alkali, hydrogen ions will react with the hydroxide ions to produce water. So if you had lithium, hydrochloric acid, for instance, the H will break away from the chlorine and make the hydrogen ions, which is what is acidic. And then if you have lithium hydroxide with the OH, those OH and that H will join together and make water, and then you end up with the other product, which is the salt, and in this case would be lithium chloride, the chlorine from the hydrochloric acid and the lithium from the lithium hydroxide. So students should be able to use universal indicator on a wide range of indicators to measure approximate pH of a solution and use the pH scales to identify something that is acidic or alkali solutions. Okay. Titrations, this is going to be for triple science only as well. So basically in here, this is another required practical, and you're very likely again to get a 6-mark question on this. Okay, this is mainly about calculating the concentration of either an acid or an alkali, depending on which one is being asked of you. Okay, is that practical? You do a titration. You have a conical flask with the acid, and then you add the sodium hydroxide little by little, and to find out how much does it require to neutralize the solution. You have the acid. I believe in this case you have an acid. You add universal indicator and it goes red. And then as you add the sodium hydroxide, the moment that it turns green, that will be the point where the neutralization reaction has happened. All you have to do is calculate the amount of sodium hydroxide you added and work out the rest of the details, okay? But it's very likely that you're gonna get a 6-mark question on this because this is a required practical, okay? Then we have strongs and weak acids. This is for higher tier only, all right? And what we got there is that basically you want to explain what makes an acid strong and what makes an acid liquid, and it has to do with the dissociation of the hydrogen ions when it's in contact with water. So you have the acid, when you put it into the water, okay, if most of the hydrogen ions break away from the, for instance, if you got hydrochloric acid, you got HCl, if you put that in water and most of the ions from the hydrochloric acid break away, that makes it a strong acid, okay? And something else, that means that most of the hydrogen ions didn't break away from the molecule, and that makes it a weak acid, but that will be a different type of acid, not the hydrochloric acid, okay? Another thing that you want to take away from that is that the concentration of an acid is not the same as the strength of an acid, okay? Because you can have a very strong acid that is diluted, all right, and you can have a weak acid that is very concentrated, and a weak acid that is concentrated may be stronger. It may be more corrosive than the strong acid because it's diluted, okay? So the strength and concentration are two different things, okay? Right, moving down to electrolysis. Over here in this section, what you want to make sure is that you understand the process of electrolysis. You got to understand that there's two types of electrolysis. You have the electrolysis of an aqueous solution, meaning that you dissolve something in water, all right? And there is the other one, which is of a molten compound, okay? If you have something like salt, okay, like sodium chloride, what will happen is that if you melt it and you put the electrodes, you turn the electricity on, sodium ions are going to go in one direction and the chlorine ions are going to go in a different direction, okay? And that's it. You're going to have just two products being made. But you got to understand where they're going to go to, because the cations will go to the negative electrode, which is the cathode, and the anions, which are negative, are going to go to the positive electrode, which is called the anode, okay? It's very, very, very easy to get those two mixed up, so you got to make sure you understand how they work, okay? The best way I'll say is to draw a couple diagrams and label them, and it will help you understand that. Using electrolysis to extract metals, okay? Now in here, the biggest example, the main example that you get is aluminum oxide, okay? Aluminum has a very high melting point, so it's not very good when you try to melt it by itself. So normally cryolite is added. Cryolite is a substance that has aluminum in there, okay? But what happens is that the aluminum prefers to be in cryolite than in aluminum oxide. So when you add the cryolite, the aluminum itself is going to break away from the aluminum oxide and go into the cryolite. Now, cryolite has a lower melting point. It has a lower melting point than aluminum oxide. So it would be a lot easier to take the aluminum away from the cryolite than taking it from the aluminum oxide. A lot of the time, the electrodes are going to be made of carbon, and because the oxygen from the aluminum oxide goes to the carbon and makes carbon dioxide, and then those electrodes have to be replaced because the carbon from the graphite electrodes goes away as carbon dioxide, so you have to replace those constantly, okay? Electrolysis of an aqueous solution. Now this here gets a bit more sticky, okay? Because say for instance, when the example I gave you about sodium chloride, you do electrolysis, you're gonna have sodium going to one side and chlorine going to the other side because that's all you have there, okay? But when you have an aqueous solution, that means that there is water involved. Anything that is an aqueous solution, that means there is water involved. So now you don't just have Na, which is positive, you also have H plus ions, which are positive. That's the hydrogen in water. And then you don't just have Cl minus, which is negatively charged, you also have OH minus, which is also negatively charged, okay? So you have two different ions, two positives and two negatives. Now the question is, which one is going to go to the electrons, okay? And normally the most reactive is the one that stays behind. So between sodium and hydrogen, because sodium is more reactive, hydrogen is going to get kicked out. And in the other side, chlorine and hydroxide, you normally get the hydroxide staying behind and the chlorine being given off, okay? That's all we got on that. I hope it did help. It's a lot to take in, but this is why your revision should be done gradually throughout the year, not just try to ram everything at last minute. Okay, if you do have any questions, drop me a comment below and I'll try to get back to you as soon as possible. If you did find it helpful, like and subscribe, share the video. But until next time, knowledge is power. So see you next time.